So we know already from the Rambam tells us that in Prakim, in chapters 9, 10, and 11, 12, the Rambam dedicates what is the length of Shnas HaChama, what is the length of the solar year. And he says, to Perek Shi Halacha Aleph, Shnas HaChama, the solar year. Yesh mechach me Yisrael shu oimer shishlosh meis chamisha v'shishim yom revi'ah yom shushei shoyz. There are some of the Jewish sages that say that it's precisely 365 days and a quarter, which is 6 hours, not more, not less. But there are those of them that say that it is less, after 365 days, it's less than a quarter day. Likewise, the Greek sages and the Persian sages of astronomy, they have arguments regarding this. Then he continues to give a long description of the Shita that it's exactly 365 days and a quarter, and how much the difference is going to be between every year, how much it's going to diminish. If then it comes out that there's a difference in 19 years. 19 years, there's an hour and 485 halakim, and he goes into great detail about it. Perek Asiri, 10th chapter begins. Aleph, Shnas HaChama, the solar year, Lemishu Oimer Shupachis Merevia Mechach Me Yisrael. According to the one who says that it is less than a quarter from the Jewish sages, Oimer, he says, Shishlosh Meis Chamisha V'Shishim Yoim, it's 365 days, v'chomish shois, in 5 hours, v'chamois shiva v'tishim chalokim, and it's 979 chalokim, u'shmoina v'arboim rega, and 48 rega, v'rega echad mishisha v'shivim b'chelek. And the question is, why did we have to take a chelek, which is already a minute part of an hour? It's basically taking an hour, dividing the hour into 1,080 parts instead of 60 parts. So each of these chalokim is 3 seconds and a third. And I'll take 3 seconds and a third and divide them out of all numbers, out of all possible numbers, to 76. What does this give significance? Why 76? Why not 48? Why not? So actually there's a method to this, there's a logic to it. And the logic is that this cheshbon, we might pay attention at the very end. After the Rambam finishes presenting these two shitas, he says as follows. Marin li advarim, halacha 6. Marin li advarim, it seems to me, shal cheshbon tkufa zu wa yusaimchin li'imyan ibur hashana. That on the cheshbon of this tkufa, they would rely when it came. Sometimes they would make a ibur yar. They would make a 13th month. So be'ez shebeis din agodil matzi, when the great Bezdin was available. Shein ma'abrin pnei azman pnei atzedach. So they would they rely on tkufas of Ada, or they would on Tkufas Shmuel, which is the first Kufa that says it's precisely 365 days and a quarter, or where they rely on Tkufas Shmuel, on Tkufas Ravada, which is this Tkufa that he just gave, that it's a little less. He says, it seems that on this cheshbon, on the cheshbon of this Tkufa, why? This cheshbon is true more than the first. Now, if one of them is correct, the other one is not correct, he should have said, what kind of language is it? It means that it is truer more than the first, but maybe not necessarily total truth. And why not? So actually, if we go to Perek Yud Beis, we'll find a new dimension, a new measurement of the solar system, which agrees neither with Tkufas of Ada nor with Tkufas Shmuel. And since the Rambam doesn't say it explicitly in this phrase, so let's go into the Rambam, chapter 12, and see what it is that he says and how that has anything to do related with what the Tkufas of Ada, Tkufas Shmuel, or a total of third Tkufa. So the Rambam says as follows: how much does the sun go per day? We're talking about a day, not a 12-hour day from sunrise to sunset, but the full 24-hour period. How much does it go? We all know that a circle is divided into 360 degrees, and a degree into 60 minutes, and a minute into 60 seconds. So it's divided into 59. How much does it go per day? 59 minutes and 8 seconds. Now, this gives you such a wide margin that it would fit both Tkufas of Ada and Tkufas Shmuel. So where can we narrow it down and see a little more precise? In other words, what does it mean? How do we see from it the length of the solar year? Because the length of the solar year is when you complete 360 degrees. If per 24 hours, it's nun tasches, all you have to do is calculate exactly how long it would take it to complete 360 degrees according to this method. But in other words, it tells you how many minutes of a degree and how many seconds. Now, the Rambam actually tells us, Perikid Aleph, what if we wanted to take a second and divide it into smaller units of time? How would we do it? Do you know how they divide seconds nowadays? They divide it by milliseconds. They divide it into 100 parts, and each part is called a millisecond. But that's not the proper way of doing it. The Rambam says that the proper way of doing it is if you want to divide a second, you divide it into 60 parts, and those are called thirds. In other words, why is a second called a second? Because it's the second division. Take, for instance, an hour. The first division is into minutes. It's called minutes because it's a minute part. Then the second division, which is in the same method, you divide into 60, it's called a second. That's why in Hebrew it's called shniyot, from the same language. Shniyot means a second. So when you take a shniyah, you want to divide it by 60, those are shlishiyot. And the shlishis is divided into 60 reviyot, and reviyot into 60 chamishiyot, and so on and so forth. It is a more proper way to demonstrate. Let's take the length of the solar year. Does anybody know what the length of the solar year is? So if you go into Google, you usually see 365.24, because 0.25 is exactly a quarter. If it's less than a quarter, it's 0.24 and change. But can anybody list the digits that are listed after 24? Practically nobody, because they're meaningless. Whatever it says doesn't mean anything to you. But if I said it was 365 days and 5 hours and 48 minutes and 49 seconds and 4/5 of a second, how hard was it? It wasn't hard at all. That's easy to remember. In other words, instead of making one huge number, which means nothing, just because it's divided by 10, it's by the decimal system, you'd rather divide it into a unit of 60 and another unit of 60 and so on and so forth. So how exactly does, now this amount that I told you, 365 days, 5 hours, 48 minutes, 49 seconds, 4/5 of a second, that comes out from this Rambam. How? Now, obviously, what does he tell you? When he's telling you 59 minutes and 8 seconds, what's missing? It doesn't tell me how many thirds. It doesn't tell me any fourth. There's some change over here, which Rambam's not. How do I know this change exists? Because then he continues, calculate how much it goes per 10 days, 9 degrees, 51 minutes, and 23 shniyos. So the Pirush, which is printed on the side of the margin of the big Rambam, poses a question and says, wait, 9 degrees and 51 chalokim and 20 seconds is exact multiple by 10 of 59/8. But where did these extra 3 seconds come from? 3 is not, so he says these 3 seconds, they came because really there's an extra 20 thirds that we didn't mention. Because the Rambam only mentioned seconds. But 20 thirds over 10 days, it adds up. It's 200 thirds. So every 60 thirds becomes 1 second. So we have 3 full seconds. Okay? Which explains also why the following, and Simonum test on Aleph Chav Gimel v'nimtza, Malacha b'mei. Rambam continues. How much does go per 100 days? Shmoina v'tishim mailis, 98 degrees. V'shloisha v'shloishim chalokim, 33 minutes. V'sholosh v'chamishim shniyos, and 53 seconds. So again, it's the same question that 89 degrees, 33 minutes, and 50 seconds is exact multiple by 10 of the previous cheshbon that Rambam gave for 10 days, 9 degrees, 51 chalokim, and 23 shniyas. But where did these new extra 3 shniyas come from? Same explanation. We said there were 200 shlishiyos for 10 days, so 180 of them, we made them 3 shniyas. But what happened to the new 20 shlishiyos? We didn't count them. But over 10 days, those are 200 shlishiyos. So again, we take 180 of those 200 shlishiyos, we make them 3 shniyas. They're added. But the Ralbach asks, if that's the case, why, when it comes to 1,000 days, don't we add? He says, then what's the leftover, the remainder of its motion for 1,000 days after you throw away every 360 degrees? It's Masayim v'chomish v'shish mailis v'shmoina shloishim chalokim in 38 minutes, v'chamishim shniyos in 50 seconds. Oh, there's no 3 seconds, extra 3 seconds over here. Why not? There should be. We said there were another leftover 20 shlishiyos, right? So multiple by 10, there should be another 3 shniyos by here. And the Rambam also gives, what do you say?
How many years does it take all the seconds on one day and drop all the
Whatever. The bottom line is, when it gets to a shniyah, the Rambam starts counting it. So if it's really 20 shlishiyos, right, the original change was 20 shlishiyos, and Werner Retnach is 20 shlishiyos and change. But just from 20 shlishiyos, so the same thing when it comes after 100 days, when it comes to 1,000 days, there should be again from the extra 20 shlishiyos, there should be another 3 shniyos, and Rambam doesn't add another 3 shniyos. Same thing comes to 10,000 days, he doesn't add another 3 shniyos. So that's one question. Another question Ralbach asks, the Rambam also gives you how much, he says in Halacha, towards the end of Halacha Aleph, it's ready to be prepared for you. You should know how much the sun goes for 29 days and 354 days. Why? Because 354 days is a regular year if the Mantar Kasidra. And he tells you exactly how much they are. It goes for the very last statement in Halacha Aleph is Halacha Lashon Astura is Sholish Meis Shmoina V'Arbaim Mailis, 348 degrees, 55 minutes, 15 shniyos, and 15 seconds. So the Ralbach poses the following question. He says that if I was to divide ten days by 5, or goes for 1 day by 4, seconds. Hanover, who wrote a book to explain the Rambam, about 300 years ago, and he explains, really, according to the Rambam, it is not, there are no 20 shlishiyos, there's less, it's 19.48. In other words, 19 shlishiyos and 48 reviyos. So obviously it comes out, and after 100 days, there's no change. No change. That explains it. But what do you do about the second question? It says, actually, how do you write 15 in Hebrew when you want a sign language? Right, Tezvav. So really it said Vites, and it was a mistake, and from Vites became Tezvav, it really means Tes. Now the problem is, maybe in our prints it says Tezvav. But in the Rambam, he doesn't say Tezvav, he just says V'chamesh Shniyos. It's just when it comes to the Siman, he gives you Tezvav. But the number writes out in full, and Teish and Chamesh are not even related. So when Yale published its Rambam, there was, this is in the 1950s, they published the Rambam. And there was a professor, his name is Niebuhr. And he came up with, he said, let's examine the Rambam, where does he get all his data from? And he tells you how much it goes per day, And then he tells you where the position was at the particular year. So in order you should make calculations. Where does he get all that data from? And the Rambam later on in chapter 17 is going to tell us that he took it from the Greeks. So there was in the times of the Mishnah, there was in Egypt, in Alexandria in Egypt, there was a guy called Ptolemaios. He wrote a book, which I think he named Principia Mathematica, Principles of Mathematics. That's, I think, a Latin name or Greek name. But in any case, the Arabs, when they translated into Arabic, hundreds of years later, they called it the Al-Majestic, the Majestic. Al is like the same thing what Al is doing in alcohol and algebra. Al is the in Arabic. The Majestic book was such a great book, and they called it Al-Majestic. It's known as Al-Majestic. And it's since been translated back into English and whatnot. And this author lived in the times of Rabbi Meir, Reb Shimon, Reb Yehuda, in the year 3901. That's the last calculation he makes. So apparently that year he wrote the book. And then there's hundreds of years later, there was an Arab astronomer about 300 years before the Rambam. His name was Albertini. And the Rambam, the data that he copies over here, how much the sun goes per day and per 10 days, and 29 days and 354 days, he takes it from Albertini. It says as follows. If I want to know the precise length of the solar year according to Albertini, now Albertini, or the precise amount that it goes per day with all the change, the amount of shlishiyas of the iyais, chamishiyas. What I should take is the largest amount that he gives, which is 354 days, which is exactly as the Rambam says, 348 degrees, 55 minutes, and 15 seconds. Divided into 354 equal parts, and here you get all the change. And it comes out that it's 20 full shlishiyas plus some revi'iyas and chamishiyas. It's 59 minutes, 8 seconds, 20 shlishiyas, 46 revi'iyas, 56 chamishiyas, and 14 shishiyas. So it's much more than what Rav Hanover said. So if that's the, what? No, first we want to get the data. We're talking about the precise length of the solar year. In order to get what the cheshbon of Albertini is, because he also, like the Rambam, he only tells you how much it's in minutes and seconds. He doesn't tell you how many thirds there are, fourth, fifth, sixth. If I want to get the change, where do I get that change from? That's the largest number he gives you. When you divide that into 354 equal parts, you will get the exact precise amount of shlishiyos, revi'iyos, chamishiyos, shishiyos, all the change. How much it goes per day? No, 354 in 354 days, it goes 348 degrees. When it goes 360 degrees, that's a year. Now, according to Albertini, what is the length of the solar year? It's a little less than that of the Rambam. It's a little less than what modern science says. It's 365 days, 5 hours, 47 minutes, and 40 seconds. Now, why did he come up with that number? Because that's a little round number. How's it round number? I think he took off, he said minus 1/300th part of the day. So you're talking about 12 minutes and 20 seconds. Which is 12, each minute is 60 seconds. So you're talking about 740 seconds. So it comes out to, you divide the day, it comes out some 1/300th of the day. There was some roundness to it. But here is the Pele. Now, how did the Rambam, so now the question is to the contrary. If that was the base of Albertini, so how did the Rambam get to tell you that in 100 days, he didn't give you that change of 300? So he explains. He says like this: Albertini, he gives you how much it's per 10 days, but he doesn't give you how much it's by 100 days. He doesn't tell you how much it's for 1,000 days or 10,000 days. So how does the Rambam calculate that? Because Albertini gives you not only for 29 days, he also gives you for 30 days. So the Rambam tripled the amount for 30 days by 3, added his number on 10. You have 400 days. But when it came to 1,000 days, he didn't have any round number to multiply. The only way you can multiply is take 100 and multiply it by 10. That's why you'll see there's about 6 different calculations that the Rambam gives. If you're in Perikid Beis, if you're in Perikid Himmel, when you'll compare the amount of 10 days to 1 day, the amount of 100 days to 10 days, 1,000, and you'll see 10,000 is always an exact multiple by 10 of 1,000. 1,000 is always an exact multiple by 10 of 100. But 100 is not always an exact multiple by 10 of 10, and 10 is not always an exact multiple by 10 of 1. For that reason, because Albertini had his base number, which he had, and that's what he used in order to give you how much is 10. But so the Rambam actually ended up rounding off Albertini's numbers. And yet, the Rambam is the one, even though they claim now that they claim that Rambam says in Perikid Aleph, the speed that the sun goes per day doesn't change one iota, not from over 500 years, not over 1,000 years. They claim that it does. They say that over 800 years, it diminished by 3 seconds. Where in the times of the Rambam, they agree that it's almost to the dot. As the Rambam says, 365 days, 5 hours, 48 minutes, 49 seconds, and 4/5 of a second. I think they claim it's 3/5 of a second, but mamish in a very minor difference. But they claim that now it's not 48, it's not 49 seconds, it's 45 seconds, 6 seconds, whatever. Diminished by 3 seconds over that amount of time. But yet they agree that in time of the Rambam, it's mamish to the tilt. And the question is, how is it possible that Rambam, by rounding off the numbers, achieves the exact number? In mathematics, if I say that anything is an accident, take the whole field and throw it in the garbage. So there's only one explanation that seems to be valid. We all know from the Medrash and Zohar tells us that the Medrash says that very first item in Medrash Rabbah is that the Torah is the blueprint of the world. The Zohar says that Istakel Beiraisa Bara Alma, the Eibishter looks in the Torah and creates the world. Which begs the question, why does the Eibishter have to look into the Torah? Beiraisa Torah and the Eibishter is all one. The Eibishter have to look into himself. We all know who v'yidiyasa yachad, who amado yidei it was. Why does he have to look into the Torah? But now we'll understand. Who incorporated all of this, which was part of science? Who incorporated the Torah? The Rambam. And the Rambam took from some scientists. But the way the Rambam incorporated it into the Rambam, that made it, so when the Eibishter just set the length of the sun, the solar system, at the beginning of creation, could have set it any length he wants. The Eibishter looked at the Rambam, saw how the Rambam says that in 10,000 days, so he says, okay, we'll make it that way. I just want to address before we conclude. So, how do we get back to what? Oh, so why is it more true? Because it's not completely true. The Tkufas of Ada is not completely true. Rav Ada says it's 5 minutes less than 365 days. It's not 5 minutes less, it's 11 minutes less. So now the question is, what? It's closer, but who needs Tkufas Rav Ada? What purpose does it serve? Obviously, Rav Ada's purpose, Rav Ada's Tkufa must serve a certain purpose, which is why it exists in the first place. Especially since we know in Torah there's no accidents. It's not a guessing game. In a calendar, it's not so important to have the perfect number as much as it's important to have a round number, which explains why Tkufas Shmuel says 365 days and 6 hours precisely. Yes, so it's a little off, but it's much easier to make these calculations. But Rav Ada twists himself into a pretzel, minus 82 82 chalakim and invents this new unit called Regoim. What's the purpose? The purpose of Avada is that the solars, we have a 19-year cycle, right? In 19 years, we have 235 months, because we have 12 Shana Pshuta, 12 months of 12, right? 12 times 12 is 144. We have 7 of 13, which is 91. Together, you have 235 months. So in 235 months, and every month, there's 29 days, 12 hours. I don't want there to remain not any more chalakim in the 19 years, right, of Shnas Achama over the 19 years of Shnas Lavon. I don't want there to be any change. So what do? I take a chelik and I divide it into 19 parts, right? But each of these parts, I have to divide into 4 parts. Why? Because not enough to tell you how much it goes per year. I want to know how much it goes per tkufa. Every year, I divide into 4 cycles. There's tkufas Nisan, tkufas Tishrei, tkufas Tevis, tkufas Nisan, Tammuz, Tishrei, and Tevis. Nisan is when it's on the equator going north. Tammuz, it's on north, furthest north it can be going towards the equator. Tishrei is when it's on the equator going south, and Tevis is when it's south and it's starting north towards the equator. So that's why we divided, and the Takasid of Ada is perfect in that there's no change. And that's the point of Tkufas Ravada. That's the purpose that it serves. You want to know you have to start from the beginning of the Machzor, and because every beginning of the Machzor every Machzor is exactly same amount of cycles of the moon, and 235 cycles of the moons equals exactly 19 cycles of the sun. No change. That's the advantage of Tkufas Ravada. So I just want to finish off. So they claim that by now it's a few seconds less. So basically what they say is that the moon goes a little faster and the sun goes a little faster. And that's why there's a few seconds less per year. There's in the times at Tzemach Tzedek, there was an astronomer by the name Chaim Zelig Slonimsky. He's known by his acronym Chazas. And he wrote a book, Untitled Chapter. We have 2 copies of it in the library. One might seem even to be in his own handwriting, but somebody makes perfect diagrams. In those days, obviously, it was very difficult to print diagrams. So wherever the diagram should be is space. So in one copy, it's just left blank. But in the other copy, somebody filled in what seems the perfect pictures. For all I know, it might be the author himself. But in any case, so he points out when it comes to this, to the claim of the modern scientists that the seconds are less, he says it's an interesting phenomenon. In the exact same proportion that the sun became quicker, in the exact same proportion the moon became quicker, which begs the question, of course, if everything became quicker, what is that one thing that remained constant against which you're measuring the speed of the sun and the moon and saying that quickened the pace? And it seems we're talking about the mechanical clock. So according to Chassidus, it's exactly vice versa. We know in Chassidus it says that there's a difference between Tzva Shamayim and Tzva Oretz. That Tzva Oretz is kayomim b'min, but not b'ish. The species of ox that exists in Rishayis Mei still exists today. But the original ox that was created by God, long gone. Adam Rishon, he's no longer alive, will be resurrected when Mashiach comes. But Masha'enkin, the sun and the moon, they're still as strong as they were originally. So Memela, it makes more sense to say that the sun and the moon retain their speed. It's just the earth, whatever it is that they're measuring with the atomic clock, that slows down a little, and therefore it seems that everything else is going faster. Should be zeicha to be as Mashiach, taken from Yad Mamish. But the main thing is, comes Rosh Chodesh, you have to look for the moon. Do you know where to look for the moon in Rosh Chodesh? When? What time of the night do you look for the moon? You don't know. Rosh Chodesh, you're going to see the moon. Not Rosh Chodesh, at the alignment itself, you cannot see the moon. But after the alignment, the earliest time that you'll be able to see the moon, it would be in the evening. What? A little after sunset. Huh? Yeah, so the Rambam gives a cheshbon. It comes out a minimum of 18 hours after Meilad HaAmiti. That's why the Rambam goes into all lengths to discuss Meilad HaAmiti. 18 hours before. But 18 hours before, where you're going to see it, you're going to see it in the east, you're going to see it at the end of the night. But 18 hours after, you're going to see it a little after sunset and the beginning of the night. Because not long afterwards, what happens is, which direction does the sun and the moon go? They travel from Ma'ariv to Mizrach, west to east, the opposite of the Galgal HaYom. So what happens is, the moon obviously goes faster than the sun. The moon completes a full revolution around the earth in 27 days and 8 hours. The amount of 29 days and 12 hours and change is the amount, because during the time that the moon is traveling, the sun didn't stay in one place. The sun is also traveling. So for the moon to catch up to the sun, that's what takes 29 days, 12 hours, and but the revolution of the sun and the moon itself around the earth is 27 days and 8 hours approximately. So when the moon surpassed the sun is now east of the sun, right? Because they're going from west to east. So what happens? The sun, because the Galgal HaYomi, the sun sets in the west. Now the moon is east of the sun, but it's not that far east of the sun. So not long after the sun sets, so does the moon. So when are you going to see at the beginning of the month and the very end of the month, you cannot see the moon during the day. You can only see it at night, after sunset or before sunrise. So when it comes at the end of the month, when the sun is ahead of the moon, right? So the moon is west of the sun. So after the sun sets, you can't see the sun anymore. But before the sun rises, you can see the moon. So the moon that you're going to see, the old moon, you're going to see in the morning in the east. Yeah, before sunrise. Masha'en came after, once the new moon happened, the alignment of the moon and the sun happened. Now you're going to see the new crescent. You're going to see it after sunset. From about 20 minutes after sunset till about 40 or 60 minutes after sunset. Yeah. Right. That's why everybody has to go out and look for the new moon. So if the Bezdin is coming, Mr. Hashem will be a Bezdin, and you'll be able to come forward and say you saw the new moon, but it'll only help if you actually look for it. So what's interesting is Rosh Hashanah is usually when it's possible that the new moon should have been seen. Because the way we do, you did already Perek Zion? Okay, you explained the concepts of Perek Zion. So we establish, as long as we try to do it on the day of the Moiled, as long as the Moiled Amtsoi is earlier than midday. Why? Because if it's earlier than midday, then there's a possibility that you'll see it that night. Because the first 6 hours, there's no way you can see it. But however, since the 18 hours that we spoke about is 18 hours after the Moiled HaAmiti, but from Moiled Amtsoi, you cannot see 6 hours afterwards. 14 hours, the max that you can have between Moiled Amtsoi and Moiled HaAmiti. So